Hi everyone, it's Angelo here with my first project status update. The topic of my final project is displacement, stress, and strain distributions in a A516 steel pressurized pressure vessel. The overview for the first project status update is given here. First I will go over my problem description, and then go through my modeling strategy, and then finally go over the validity and reliability verification, how I plan on showing that my results are accurate and trustworthy. Here is my problem description. My problem is in regards to the stresses, strains, and displacements that occur on a A516 vessel while it is held under pressure. A516 is a carbon steel designation, so we are looking at carbon steel vessels. There are many different factors and setups that can affect this problem, such as the vessel geometry, the vessel method of construction, such as are components welded together versus bolted, and the relative pressures inside versus outside the vessel. Commonly for these problems you have a very large pressure inside the vessel and it is ambient pressure outside, but it is possible and it occurs when there is a relative pressure outside of the vessel as well. For most of my project I will focus on the most common setup, which is a cylindrical vessel with a rounded top and bottom, so a pill-shaped vessel, and we can look at either with the end caps being bolted on or welded, as stated earlier. Common applications of these carbon steel pressure vessels. Carbon steel has a very high tensile strength, and as such the use of these pressure vessels are found all over in industrial manufacturing. Two common applications are used as boilers and as compressed air reservoirs. My modeling strategy. For my modeling strategy, I plan on taking advantage of COMSOL and its ability to demonstrate the finite element method, and also its ability to give out and spit out solutions to the equations, paying close attention to the hoop stresses, which are the axial stresses along the side of the cylinder. I can start with a 1D model, which is just a section of the wall thickness, basically a line from the inner diameter to the outer diameter of the wall. The 2D model is just a 360-degree extension of the 1D model, which will give a ring, a cross-section of the cylindrical vessel. Then finally the 3D model, which is obviously just the full cylindrical vessel, taking into account both the rounded end caps and obviously using cylindrical coordinates. I will also be performing mesh extension studies, going from a very coarse mesh to a very fine mesh, and I would like to also run these tests using both first order and second order Lagrange polynomials, and seeing how the results change with that. For the validity and reliability tests, I would plan on plotting my results using COMSOL, and then also using Maple to determine the exact solution and plotting that as well. And I will be able to use Maple to compare plots of the finite element method solution and the exact solution, and that will tell us exactly how accurate and precise the finite element method studies were. Thank you everyone, that's it for my first project status update.